My dear students, hope you are all well. And today, uh, my topic of the discussion of this class is general preparation of aldehydes and ketones. General preparation of aldehydes and ketones. And before starting this class, I must request you to subscribe my channel. Okay, because your subscription motivate me to prepare more tutorials for you. Okay, and I also request you not to skip any single second. Okay, because everything I will discuss with you, I am not writing on this whiteboard. Okay, so you must listen all the words very carefully. Okay, so general preparations of aldehydes and ketones. So at first, one thing, primary alcohols. I am starting from primary alcohols. Primary alcohols. Okay, so what is primary alcohols? Primary alcohols like this are CH2OH. That means this is the alpha carbon. The astatic carbon is the alpha carbon. Why it is alpha carbon? Because alpha carbon is that carbon atom to which the functional groups are attached. And with this alpha carbon atom, only one alkyl group is attached. Only one alkyl group is attached to the alpha carbon atom. So, as only one alkyl group is attached with this alpha carbon atom, and rest of the two bonds are occupied by hydrogen atom, this alcohol is called primary alcohols or 1 degree alcohol. Primary alcohols or 1 degree alcohol. Okay. So if you oxidize the primary alcohol, if you oxidize the primary alcohol, you will get aldehydes. If you get oxidized primary alcohol, you will get what? You will get aldehydes or CaO. And one thing, no loss of carbon atom. No loss of carbon atom. Remember, no loss of carbon atom. The numbers of carbon atom present at this alcohol, 1 degree alcohol, is as similar as that present in the molecule of aldehydes. Okay, and if you again oxidize this alcohol, you will get carboxylic acid. What you will get? Carboxylic acid. That is RCO OH or COOH. Clear? So our today's topic is the preparation of aldehyde. So we should stop here. We should not move further to the carboxylic acid. Okay. So we should stop here at the aldehyde level. And here oxidize means in presence of nascent oxygen atom. The reaction in presence of nascent oxygen atom. And if you start the oxidation process from secondary alcohol, that is two alkyl groups are attached with the alpha carbon atom. Two alkyl groups are attached with the alpha carbon atom. Secondary alcohol means 2 degree alcohol. Secondary alcohol means 2 degree alcohol. That is, two alkyl groups are attached with the alpha carbon atom. And if you oxidize the secondary alcohol, you will get what? Ketones. And here again, no loss of carbon atom. No loss of carbon atoms. This is ketones. So from primary alcohol after oxidation you will get aldehydes, and from secondary alcohols after oxidation you will get ketones. Okay. So what are the oxidizing agents? This is the main thing. What are the oxidizing agents? Okay. So I will write here some names of the oxidizing agents. Okay. So I clear the whiteboard. So what are the oxidizing agents? Number one, potassium dichromate, K2 Cr2O7 plus H2SO4, and heat. Okay, and this is concentrated potassium dichromate plus concentrated H2SO4 in presence of heat. This is the very beautiful oxidizing agents, and this oxidizing agent is capable of doing the oxidation of primary alcohol to aldehyde and secondary alcohol to ketones. Okay, and next, for ketones, one thing, this is called pyridinium chlorochromate, PCC, and CH2Cl2. What is PCC? Pyridinium chlorochromate. Pyridinium chlorochromate. Okay. So if you get this kind of, look, this is a ketone. Okay. If you get this kind of ketones, then if you apply PCC, sorry, this is the alcohol from secondary alcohol. If you use PCC in CH2Cl2, so CH2Cl2, this is the dichloromethane. Dichloromethane actually acts as the solvent, dichloromethane. So if you use dichloromethane, you just give this ketone. Okay. Okay. Next, for ketones, I'll write another beautiful oxidizing agents for ketones. Another beautiful oxidizing agent is aluminium tertiary butoxide. Aluminium tertiary butoxide. Aluminium tertiary butoxide. This will be like this: CH3 whole 3, CO whole 3 Al. This is the aluminium tertiary butoxide. Okay. So this reaction This reaction is called as Oppenauer oxidation reaction. This reaction is essentially called as Oppenauer oxidation reaction. So, what is Oppenauer oxidation reaction? This reaction is called as Oppenauer oxidation reaction. Oppenauer Oppenauer oxidation. Oppenauer oxidation. So I'll discuss some. I'll discuss little briefly with the Oppenauer oxidation reaction. So let us see what is the Oppenauer oxidation reaction. Oppenauer oxidation. So what happened in Oppenauer oxidation reaction? If you start from the secondary alcohol like this, like C2H5, this is a secondary alcohol, C2H5 C8OH. This is nothing but a 2-degree alcohol. Okay, this is nothing but a 2-degree alcohol. Uh, and if you use tertiary aluminum butoxide CH3 whole 3 CO whole 3 aluminum and acetone, this is acetone in excess, then this 2-degree alcohol, this 2-degree, mind it, this 2-degree alcohol becomes ketone, C2H5 C double bond O C2H5. This is, so this 2-degree alcohol becomes ketone, and the acetone used as the solvent becomes isopropyl alcohol, like this. This acetone, mind it, this acetone becomes isopropyl alcohol. This acetone becomes isopropyl alcohol. Okay, so you may have asked, by Oppenauer oxidation, can we prepare in place of ketone aldehyde? So my question is, in Oppenauer oxidation reaction, can it feasible to, will it be feasible to prepare aldehyde? So prepare aldehydes by Oppenauer oxidation. Will it be feasible? Yes. By Oppenauer oxidation, aldehyde can be prepared, but in place of acetone, you should use para-benzoquinone. Okay, so in place of acetone use para benzoquinone as solvent. Then from primary alcohol, aldehyde can be prepared. This kind of tricky questions may have been asked in your entrance exam after class 2. Okay, so this is a very typical example. Next, so next, Collins reagent. Collins reagents. So what are the Collins reagents? So Collins reagent is the chromium trioxide pyridine. Pyridinium chromium trioxide. So Collins reagents. What is Collins reagent? Collins reagent is the chromium trioxide pyridine. Chromium trioxide pyridine. Chromium trioxide pyridine. Okay. So this is the chromium trioxide pyridine. So what is the formula? Formula is C6H5N whole 2 CrO3. This is the Collins reagent, and by Collins reagent you can form primary alcohol. If you start from primary alcohol, so Collins reagent Cr means Collins reagent. If you use Collins reagent and CH2Cl2 acts as solvent, you will get aldehyde. And if you start from secondary alcohol by Collins reagent, do means Collins reagent, you will get ketones. Okay, so this is the Collins reagent. Next one reagent is the Jones reagent. What is the Jones reagent? So next, Jones reagent. So what is the Jones reagent? Jones reagent is CrO3 CrO3H2SO4. This is the Jones reagent, CrO3H2SO4. Okay. So if you mixed, this is called Jones reagent. So this is called Jones reagent. So by the use of Jones reagent, by the use of Jones reagent, primary alcohols are oxidized to give aldehydes. Here only primary alcohol can be oxidized. Okay. So what is the primary alcohol? R, CH2OH, and Jones reagent CrO3 plus H2SO4. This is a Jones reagent, and by the use of CrO3 H2SO4, the actually H2CrO4 is produced. It is the main oxidizing agent. H2CrO4, it is produced and it is the main oxidizing agent. So it will give RCHO aldehydes. Okay. So now move some selective oxidation. Okay. And here it should be mentioned that chromium chromium is very toxic in nature. Okay. So some modification is applied when chromium is used as the oxidizing agent. It can be Jones reagent, it can be Collins reagent. Some modification is occurred, and this is called Swern oxidation. Swern oxidation. Swern oxidation. So, as the oxidizing agents using chromium is very toxic in nature, in place of chromium, some modification is being done. So, here in place of chromium, dimethyl sulfoxide is used. Dimethyl sulfoxide is used. Dimethyl sulfoxide. Okay. So, now dimethyl sulfoxide. Dimethyl sulfoxide. Here again not only dimethyl sulfoxide plus dimethyl sulfoxide plus oxyl chloride, oxalyl chloride, oxalyl chloride plus triethylamine, triethylamine. So this is the reagents. This is the reagents of Swan oxidation. Okay. So here again, by Swan oxidation, by Swan, what happened? By Swan oxidation, primary alcohol, from primary alcohol, aldehydes, and from secondary alcohol is called ketones by Swan oxidations. Okay. Swan oxidation, SO, Swan oxidation, SO. Okay. So we have to remember the reagents in Swan oxidation. What are the Collins reagent? What are the Jones reagent? You have to remember. Okay. So today I will stop here because otherwise we will be overloaded. In our next class we will see some more methods of preparation of aldehydes and ketones. Okay, so I am not going through the details of the mechanism. I only give examples and the outlines, and hope you will enjoy my class. And this kind of tricky questions may have been asked in your exams, in basically in entrance exam after class 12. So you must prepare accordingly. So my dear student, I should stop here today. Okay, in our next class we will meet again. So goodbye.